Welcome everyone to where we are putting together solutions to those math and science problems that students are getting. In this video, we will be looking at CSEC Mathematics and the topic of algebra. We'll be specifically looking at the question that comes in paper 2 for the years May 2014 until 2018. Feel free to like the video and add any comments down below so we can create other videos to help you in any other areas that you're getting problems with. Don't forget to look at the description down below to follow the order to cover the entire CSEC Maths syllabus. Let's recap the 10 major topics in CSEC Math, and this video deals with topic number 6, Algebra. This topic comes in both section 1 and section 2 of the long paper. Let's recall that algebra is tested for 6 questions out of the possible 60 in paper 1, and in section 1 of paper 2 it comes as 1 full question worth 10 marks. In this video we'll be looking at the solutions from 2014 all across to 2018, and each year the question was tested as number 2 of the past papers. May 2014, number 2A. Write as a single fraction in its lowest terms x minus 2 over 3 plus x plus 1 over 4. This exact question came a couple years earlier and we did it in our last video, and we'll repeat the solution here. My suggestion would be, as we've seen over the years where students get problems, the first thing we should look at is use the whole numerator as one item. So the way we deal with that is we put parentheses or brackets in the numerator. As such, we write it as open brackets x minus 2, close brackets, all over 3, plus open brackets x plus 1, close brackets, all over 4. So now if we look at this would be just as if we were adding 2 fractions with different denominators. And we've done such questions where we've outlined the steps to follow that in the topic of computation. So you can take a look there at those videos to recall the steps. Now, what should we do when we have denominators that are different? Then we should try and use one common denominator. So the easiest way would be just to multiply 3 by 4 or find the LCM. So 3 4s are 12. That means we want to change each of the fractions to something over 12. So let's look at the first fraction, x minus 2 over 3. How do we change that to something over 12? Well, we multiply by 4 in the denominator. 4 times 3 is 12. And if we multiply by 4 in the denominator, then we should be multiplying by 4 in the numerator as well. And for the second term, the denominator is 4. So how do we get 12? We multiply by 3. So we multiply by 3 below, 3 times 4, and we multiply by 3 on top in the numerator. Now, we can rewrite this since both fractions have the same denominator, and we can expand the top. So 4 times x, remember if we have 4 outside our brackets, it means the 4 is multiplying each of the terms. So 4 times x is 4x, 4 times 2 is 8, and we have a plus 4 and a minus 2. Different signs. Same signs, add, so different signs, we put a minus. So it's 4x minus 8. And then we have plus 3 times x is plus 3x, plus 3 times plus 1, 3 ones are 3, plus 3. Now, if we look at the numerator, we have 2 terms in x, so we can simplify that, and we have 2 terms with no variables, so we can simplify that. As such, 4x plus 3x is equal to 7x, minus 8 plus 3 is minus 5, all over 12. Now for part B, write an equation in x to represent each statement below. Do not solve the equation. Part 1, when 4 is added to a certain number, the result is the same as halving the number and adding 10. Now if you notice, this question is only worth 1 mark, So we basically need to write one line. So let's think of a number, and let's use everybody might have a different number they'll think of. So let's use one general term to represent all the numbers. Let's call it n. So when 4 is added to a certain number, so let's say n plus 4, the result is the same as, so we can say n plus 4 is equal to halving the number, n over 2, or half n plus 10. And for part 2, squaring a number and subtracting 6 gives the same result as doubling the number and adding 9. So if we still consider a number n, squaring the number would be n squared, subtracting 6 means minus 6. So n squared minus 6 gives the same result. So n squared minus 6 is equal to doubling the number. That means 2n plus 9. May 2014, number 2C. John drew the diagram to show what he was thinking. So let's look at the flow diagram that he drew. He had the input, he called it x. Then he multiplied that by 3. And when he got this result, he added 5 to it. And that was his output, which he called y. So part 1, use the information from the diagram to write a formula for y in terms of x. So we need to have y equal to something. Now it's worth 1 mark, which gives us an indication that pretty much all we need is one line of working. So y is equal to, what did we do with x? We multiply by 3 first of all. So y is equal to 3x plus 5. Part 2. If the number 4 is the input, what number would be the output? So let's recall, we have a formula we just wrote, y is equal to 3x plus 5, and they're telling us the input. They're telling us what x is. X is equal to 4, so we can substitute that into the equation, and we'll now write y is equal to 3. Don't write x, we can replace it with 4. So 3 times 4 plus 5. 3 4s are 12, 12 and 5 is 17. And if we put it up in the flow diagram above and we try it, 4 multiplied by 3, 4 3s are 12, 12 plus 5 will give us 17, the same thing. Part 3, if the number 8 was the output, so now they're giving us the answer. They're giving us the end product. What number was the input? So we can follow the flow diagram and work backwards, or we can use the equation that we had. So let's try it both ways. We call y is equal to 3x plus 5. And if we substitute y, because that's the output, is 8, into the equation, then we get 8 is equal to 3x plus 5. And if I want to find x alone, I need to get rid of the stuff from the right hand side. So the first thing to remove is the plus 5. When I carry it across, the opposite of adding 5 would be additive inverse, or subtraction. So we'll have 8 minus 5 is equal to 3x. 8 minus 5 is 3. 3 is equal to 3x. And if I want x alone, what the 3 is doing on the right hand side is multiplying. When I carry it across, it'll do the multiplicative inverse, or better known as division. So 3 divided by 3, so our answer is 1 is equal to x. And if we look into our flow diagram, let's substitute x as 1. And let's see what we get. 1 times 3 is 3. 3 plus 5 is 8. So we got our output as 8, therefore we're on the right track. Now, for part 4, reverse the formula written at C part 3. Reverse the formula above to write x in terms of y. So you'll find this looks like a relations and functions question where they're asking us to get it going in the opposite direction. Normally we call f inverse. So we call y is equal to 3x plus 5 and we want to find x alone. So we follow the same format like what we did in part 3. We want x alone, we need to remove the 5 from the right hand side. That will give us y minus 5 is equal to 3x. Exactly what we did in part 3. And if you want x alone, it will be y minus 5 over 3. May 2014, number 2D, the last part of the question. Solve the pair of simultaneous equations. 2x plus 3y is equal to 9. So let's call that equation 1. And 3x minus y is equal to 8. Let's call that equation 2. And as we said before, there are multiple ways to solve this. If you're good at sketching graphs, then you can make the graph and draw the two lines together and where they intersect. That's the point. If you're good with the matrix method of solving simultaneous equations, use that. Elimination and substitution, Cramer's rule, or whichever one you prefer. In this case here, I'll be showing you the substitution method. So let's pick any equation. Which one can we identify one variable by itself quickly? Well, it seems that equation 2, we have 1y. So let's work on that. So from equation 2, 3x minus y is equal to 8. If I want to isolate y alone on one side, we could carry the y across. And there are different ways to do this as well. You'll still end up with the same answer. So if you carry the y across, the y is subtracting on the left-hand side. When I carry it across, it will add. So we get 3x is equal to 8 plus y. And if we want y alone, we need to remove the 8 from the right-hand side. It's plus 8. It's the sign in front of the 8, not behind. So we have plus 8, even though the plus is not written. When I carry it across, it'll do the opposite of that, which means it'll be 3x minus 8 is equal to y. So let's say that's a new equation, equation 3. It's really a different format of equation 2. Now that we know that, let's substitute that into the equation that we did not use so far, which was equation 1. So 2x plus 3y is equal to 9. That's equation 1. And what do we know? We know y. So let's replace the y in that line. So let's rewrite 2x plus 3, and in brackets, not y anymore, 3x minus 8. And that will be equal to 9. It's a simple substitution. That's why the method is that name. So 2x plus 3 times 3x, that's 9x. 3 times 8 is minus 24 is equal to 9. And we have x's and we have numbers alone. So let's keep the x's on one side and let's keep the numbers on the other side. And then we'll be able to simplify. So let's rewrite. 2x plus 9x is already on the left hand side. Leave it there. Just take the minus 24 and carry it across. So we'll have 9 plus 24. And the left hand side will work out to be 11x is equal to 9 plus 24 is 33. So if 11x is equal to 33, x is equal to 33 divided by 11. Because 11 on the line above was multiplying on the left hand side. So when you carry it across, it will divide. So 11 to 33 is 3. So x is equal to 3. So we found the value of x in order for these two equations to meet. So let's substitute x is equal to 3 into any one of the three equations. I'll pick equation 3 because it looks the simplest. Y is equal to 3x minus 8. And we know x is 3. So we rewrite the equation, substituting the x value in there. So y is equal to 3 by 3 minus 8. So y is equal to 3 3s are 9 minus 8. Y is equal to 1. So when x is equal to 3 and y is equal to 1, both equations are satisfied, meaning that both equations intersect if we were drawing a graph. And the question is finished. We got our 3 marks, and let's substitute it into there to see if it makes sense, if it's correct. So for the first equation, 2 times 3 is 6. 6 plus 3 ones are 3. That gives us 9, is correct. And for the second equation, 3 times 3 is 9. 9 take away 1 is 8. So that works as well. May 15, number 2a. Given that a is equal to 4, b is equal to 2, and c is equal to minus 1, find the value of, for part 1, a minus b plus c. So this is a simple substitution because they gave us the values of the three variables a, b, and c. So we can just substitute and find. So that will be equal to, what is a? 4 minus, what is b? 2 plus c is minus 1. So 4 minus 2, and we have a plus and a minus 1. When we have two different signs, then it is subtract. So 4 minus 2 minus 1. 4 take away 2 is 2, 2 take away 1 is 1. So we've evaluated part 1 and the value we got was 1. For part 2 of the question, we're still finding the value of 2a to the power b. And we know a and b, so we can substitute 2 by 4 to the power 2. And what do we work out first? We work out the indice or the power first. So 4 to the power 2 or 4 squared. 4 4s are 16. So 2 times 16, and that will give us 32. For part B of the question now, a bottle contains 500 milliliters of orange juice. Write an expression for each of the following. The amount of juice left in the bottle after pouring out P milliliters. So if we had 500 and we emptied out P, what do we have left? We have 500 minus P milliliters. And for part 2, what is the amount of juice left in the bottle after pouring out Q glasses, each containing R milliliters? So let's consider we had one glass. How much was being poured out? R. So one glass is equal to R. So if I have Q glasses, then it will be Q times R. That's how much. So if we had a bottle and we emptied out into Q different glasses, then how much would we enter? We'll be emptying out QR. So what is the amount that remains? We started with 500 minus QR milliliters. May 2015, number 2C. Write as a single fraction as simply as possible 2k over 3 plus 2 minus k over 5. Now, the first step when we look at this that I've found that students get problems with is to recognize that the numerators can be considered as one item. So how do we do that? Let's put brackets around the numerator. So let's rewrite it. Open brackets 2k, close brackets, all over 3, plus open brackets 2 minus k, close brackets or close parentheses, all over 5. Now that we have it in this form, it looks like two fractions that we need to add. And how do we add fractions which have different denominators? We try to change the denominators to be the same thing. So we try to find a common denominator. So if we have 3 and 5, 3 5s are 15. So we can simply change both of them to 15. So how do we change the denominator, the first fraction of 3 to 15? We can multiply by 5. So we say 5 times 3 at the denominator and 5 times the numerator, 2k. And how do we change the second fraction to 15? Well, the base is 5. So we can take the denominator and say 3 times 5. Therefore, we multiply the numerator 3 times 2 minus k. Now that we have that, we could recognize that both denominators are 15. So we can rewrite it as one long vinculum, one long line, putting 15 below, and we can expand it up. So if we say 5 times 2k, that's 5 2s are 10k, plus 3 times 2, 3 2s are 6, and 3 times minus k is minus 3k. Now that we've done that, we recognize that the numerator has two different items with k in it, so we can simplify that. 10k minus 3k is equal to 7k plus 6 all over 15. Can we add 7k and 6? No, we can't, because one has a variable and one does not. So that's the end of the question for this part. Let's go on to part D. 4 mangoes and 2 pears cost $24, while 2 mangoes and 3 pears cost $16. Part 1. Write a pair of simultaneous equations in x and y to represent the information given above. So let's look back at the first mathematical sentence, and we want to write it as a number sentence pretty much. 4 mangoes, so let's call the cost of a mango as x, so 4x, and the 2y cost equals 24, and that will give us our first line. And the second sentence, 2 mangoes and 3 pears cost $16, then we can say 2x plus 3y is equal to 16. So part 2, state clearly what x and y represent. X represents the cost of 1 mango, because if we have 4 mangoes, then what's the cost of the 4 mangoes? 4 times x. And y represents the cost of 1 pear. May 2015, number 2E, last part of the question. Factorize completely 2 items. Part 1, a cubed a to the power or to the indices 3 minus 12a. So if we look at both of these, what can we extract? We can extract a. And if you're not seeing that, let's put a little line in between. So for those who are struggling can follow. What is a cubed? A times a minus 12a, 12 times a. So what do we see? It's the same in both of them. A is the same. So we can extract the a and we're left with a squared minus 12. Can we factorize this any further? Well, 12 is not a square number. If it was a square number, then we could use difference of squares and continue. But it's not, so we can stop right here. A, open brackets, a squared minus 12, close brackets will be the answer. Part 2. We're factorizing 2x squared minus 5x plus 3. So let's recognize that that's a quadratic equation with 3 terms. And our usual step for factorizing this. And there are different ways to factorize. We can draw the rectangle with 4 smaller rectangles inside it and use that method. But let's use the normal algebraic method that most teachers teach so students don't get confused. So what do we do? How do we split that middle term? And what's the middle term? It's minus 5x. So we'll underline that in green. So how do we split that middle term into 2 terms? Well, the method would be to multiply the 2 numbers on either end. The coefficient of x squared and the number which has no x in it. So 2 times 3, that will give us 6. So if we consider that, can we put 6 blocks to form a rectangle? Well, we can. We can put all 6 blocks in one line. That will give us a 1 by 6 rectangle. Can we shift it around to get another rectangle? Well, we could take 3 blocks from the first row and slide it across, so we'll get a 2 by 3 rectangle. Can we do anything else? Well, we can get a 3 by 2, but 3 by 2 is the same as a 2 by 3. Right? So we've covered 2 possible pairs that will give us 6. Now, which pair can we use to get the middle term, the minus 5? Well, actually, we could use both pairs, but only one pair works out to be correct. So let's use 2 and 3. So if we say plus 2 plus 3, what do we want to get? We want to get minus 5. Minus 5 is not equal to plus 2 plus 3. So that does not work. Let's try minus 5. Is that equal to plus 2 minus 3? No, it's not. Because that's minus 1. In the next case, if we switch the signs again, we say minus 5. That is not equal to minus 2 plus 3. Because that works out to be plus 1. And if we switch the signs again for the 4th time, minus 5, is that equal to minus 2 minus 3? Yes, it works. So as such, we can replace the middle term, minus 5x, by minus 2x minus 3x. So let's rewrite the line. So from 3 terms, let's go to 4 terms. So that first line will be equal to 2x squared minus 2x minus 3x plus 3. It doesn't matter which order you write it in. You could write the minus 3x first and then the minus 2x. It'll still come up to the same solution. This has been something we've been doing over and over in all the past paper questions. How do we work with 4 terms? We take the first 2 terms and try to factorize. So let's put our maroon line underneath it. And what can we pull out from 2x squared minus 2x? Or what's the same in both of them? 2 is the same. And x is the same. So we could pull out 2x. And what will be left with? X minus 1. Let's check back to see if it's correct. 2x times x, it gives us 2x squared. 2x times minus 1 gives us minus 2x. So we split the first pair. Let's see what we can do with the second pair, minus 3x plus 3. Now we know when we're factorizing, we want to get the same brackets. So some of my students quickly write x minus 1. So if we know that's what we want to end up with, what can we take out from these 2 terms that we've underlined in purple? Well, we could take out 3 plus 3. If we take out plus 3, then we'll get minus x. It's not the brackets that we want. So we should take out minus 3. So if we take out minus 3 by x minus 1, let's see if it's correct. Minus 3 times x is minus 3. Minus 3 times minus 1. 3 ones are 3. A minus and a minus. 2 negatives are positive. Or 2 same signs gives a positive. So now that we've completed this line, let's look at it. Are there anything we can extract again that we can factorize out? Yes, we can. We can pull out the brackets. The brackets are the same in both terms. So if we pull that out, what are we left with? 2x minus 3 by x minus 1. And we've completely factorized the part 2 question. May 2016, number 2a. Factorize completely part 1, 4a squared minus 16. So we have two terms. Can we pull out anything from there? Well, both of them don't have a's, so we can't pull out a letter. Can we pull out a number? Well, yes, we could pull out 4. So if we extract 4 or factorize it, then we'll get 4. And what are we left with? A squared minus 4. Let's see if that's correct. 4 times a squared, it gives us 4a squared. 4 times minus 4, it gives us minus 16. So our second line is correct. Now, a little hint. If they gave us our first line and we only wrote one line, do you think that's worth 2 marks? Writing one line of working? Maybe not. That might give you an indication that maybe we're not completed yet. So, can we factorize anything again? Can we factorize a squared minus 4? Well, there are a couple ways we can. So, one way is to take two terms and make it into 3. So, if we do that, then we can rewrite 4a squared plus, remember it's a quadratic, it's to the power 2. We can write a quadratic in terms of a, so we'll rewrite it 4a squared plus 0a minus 4. And if we recognize that, is it the same as the second line? Well, 0a has no value, so really it's the third line and the second line both have the same thing. Now, how do we handle a quadratic? How do we factorize that? Well, we multiply the numbers on the ends. The number in front of the a squared, that's called the coefficient, and that works out to be 1, 1a squared. 1 times 4 is 4. So what do we do with this 4? Well, let's consider if we had 4 squares or 4 cubes and we put them in a straight line, then can we get a rectangle from there? Yes, we can. We can get a rectangle 1 by 4. Can we rearrange the same number of squares in order to get another rectangle? Yes, we can. We can get a rectangular square, which is a 2 by 2. So, can we do any other arrangement? No, we'll get a 4 by 1, which is a 1 by 4. It's the same thing. So, basically, what we recognize is that we'll either get 1 by 4 or 2 by 2, and that will be used to replace the middle term. Now, let's recall why are we replacing the middle term? What we want to do is move from an area of 3 items to one of 4 items. So how do we get 0a? Now, can 1 and 4 give us 0 or 2 and 2? Clearly, 2 and 2 will give us 0. If we want to get 0, then both terms must be the same. So what do we do with 0? In order to get that, we must adjust the 2 and the 2 with different signs in front of it to see which one gives us that. So let's see. 0 is not equal to plus 2 because that's 4. Right? So that doesn't work. If we switch the sign and we put a minus in front of it, then 0 is equal to minus 2 plus 2. So that's correct. We could use that. And I just want to go on. What about if we tried switching the signs the other way? Plus 2 minus 2. That's 2 take away 2. That's 0. So that's correct too. What about if we switch the signs again and put both of them as negative? Minus 2, that's not equal to 0. That's minus 4. So either the second line or third line we can use to replace the line that we have underlined in green, the 0a. So let's rewrite it. So we get 4, open brackets, a squared plus 2a minus 2a minus 4. And let's recognize whether or not it's correct. If we take 2a minus 2a, that gives us 0a. That's the line above. And 0a we could ignore. That gives us the line above. So pretty much every single line we wrote is the same. So now, how do we handle 4 terms? Well, we've been doing this over and over. What we do, let's put a maroon line underneath the first 2 terms to be consistent with all the other solutions we did before, so you can follow. So can we factorize a squared plus 2a? Yes, we can. What can we pull out? We can extract or factorize a. So we have 4 by a, and what is left? A plus 2. Let's multiply it to make sure it's correct. A by A is A squared. A by 2 is 2A. And for the second set of brackets, which where we are underlining the two terms, so we have a purple line for it, then we want to get the same brackets, A plus 2. So what do we pull out? We pull out minus 2. And let's see if that's correct. Minus 2 times A, minus 2A, minus 2 times 2, minus 4. As such, this whole line should make sense. So now, can we factorize even further? Let's look inside the square brackets. What's the same? A plus 2. So we could factorize that out. So we'll get 4 by A plus 2 by what's left? A minus 2. So we've completely factorized it. Is there a shorter way to do this? Yes, we can. Let's say 4A squared minus 16. We can pull out 4. So we get A squared minus 4 just as above. And A squared minus 4, hopefully you could recognize that's a difference of squares. A squared minus 4 is really A squared minus 2 squared. And the difference of squared, A squared minus B squared, when we factorize that, is always A plus B by A minus B. So in this case, we have A and B is 2. So we can rewrite it in our final line 4A plus 2 by A minus 2. And for the next part of the question, 3y squared plus 2y minus 8. Let's factorize that. That is 3 terms, which is just like what we did in our third line in part 1. So what do? We multiply the ends, 3 by 8, and that will give us 24. So we want to put 24. Let's put 24 squares in a row, and that means that rectangle is 1 by 24. Can we shift it around to get another rectangle? We could cut it in half and shift it, so we'll get 2 sets of 12. Can we shift it again? Well, we could take 4 from each row and shift it, so we get 3 sets of 8. Can we shift it even further? Well, we could take the 2 sets of 12 and cut it and slide it up, so we get 4 sets of 6. So either 1 by 24, 2 by 12, 3 by 8, 4 by 6 will give us 24. Will give us 3 by 8. So one of these pairs we're going to use to get the middle term. The middle term is the term we have underlined in green, which is plus 2y. So we want to replace plus 2y by 2 other terms. So the equation moves from 3 terms to 4 terms. So how do we get plus 2? Let's look at the pairs. Can 1 and 24 give us 2? No. Can 2 and 12 give us 2? They're too far apart. Can 3 and 8 give us 2? No. 4 and 6? Well, maybe 4 and 6 could work. So how do we get plus 2 from 4 and 6? Let's try to add the 6 and add the 4. Plus 2 is not equal to plus 6 plus 4. That's 10. So what we're going to do, we're going to use 6 and 4. We're going to manipulate or adjust the signs in front of it until we get the correct one. That will give us plus 2. So let's put a minus sign in front of them. Plus 2 is equal to plus 6 minus 4. That's 6 minus 4 is 2. Yes, so that's correct. So the second line works and we can stop here. But let's go on so you can see the format that you should follow. So the thinking is plus 2. Is that equal to minus 6 plus 4? If we change the sign, no, that's minus 2. So plus 2 is not equal to that for the third line. And let's try a fourth way. Let's put both signs as negative. Minus 6 minus 4. That's minus 10. So plus 2 is not equal to that. As such, as one only equal sign, the second one, let's use that. So let's rewrite from 3 terms to 4 terms. So we're writing 3y squared again. And the plus 2y is replaced by plus 6y minus 4y minus 8. So 3 terms became 4 terms. And let's see, plus 6y minus 4y gives us the term in green, plus 2y. So now we have 4 terms. How do we deal with that? That looks just like what we did in part 1. We put a maroon line under the first pair and see if we can factorize it. And we can pull out 3y, so we're left with y plus 2. Let's see if that's correct. 3y by y is 3y squared. 3y by 2 is 6y. Notice every time I'm writing a next line, if one line is equal to the other line, I double check to see that is correct. And what do we do with the second pair, the pair that we're underlining in purple? Well, we have minus 4y minus 8, and we want to get something with the same brackets, y plus 2. As such, what do we factorize out? We factorize out minus 4. And let's see if that's correct. Minus 4 times y, minus 4y, minus 4 times plus 2, 4 2s are 8. 2 different signs, it's a negative. So the third line is correct. What is the same in both of them? We have brackets that are the same. Factorize that out. What are we left with? 3y minus 4 by y plus 2. And just like in the first part, when you get your final answer, and we're completed here, you can multiply it back out to see if we get our first line up on top. And that way you will know for yourself in algebra whether you got the question perfectly right or not. May 2016, number 2. Part B. Solve the simultaneous equations. 2x plus y is equal to 3. So let's call that equation 1. And 5x minus 2y equal to 12. So let's call that equation 2. So I'm going to use a method of substitution in order for it to work. So let's take which one of those equations can we easily separate a single variable. Well, if we look at equation 1, we can find y by itself, so let's deal with that. So from equation 1, 2x plus y is equal to 3. So if I want y alone, then I get rid of 2x from the left-hand side. What is it doing? Look in front of the 2. What kind of 2 is that? That's a plus 2. So we have plus 2x. If I carry it across, it'll do the opposite. It'll be 3 minus 2x. So we have reshaped the equation 1 and let's call that equation 3. Y is equal to 3 minus 2x. Now that we've done that, let's put equation 3, the y value, into which equation did we not use so far? We did not use equation 2. Now let's recall that there are many methods to solve simultaneous equations. I'm just using in this question here, substitution method. So let's substitute into equation 2. Let's rewrite equation 2 is 5x minus 2y. That's 12. And we know y. So we can rewrite 5x minus 2. And instead of writing y, we can write 3 minus 2x is equal to 12. And we could expand the brackets. And what will that give us? 5x minus 2 by 3 is minus 6. Minus 2 by minus 2x, 2 2s are 4, so that gives us plus 4x is equal to 12. And we have 4 terms on this line. 2 terms have x's in it, 2 terms have numbers only. So let's keep the x's on the left-hand side and the numbers on the right-hand side. So we can rewrite it. Let's carry the minus 6 across. So what will be left on the left-hand side? 5x plus 4x is equal to 12. And the minus 6, when we carried it across, became plus 6. So 5x plus 4x is 9x is equal to 12 plus 6 is 18. And if we know 9x is equal to 18 and we want to find x alone, what is the 9 doing? The 9 is multiplying. When I carry it across, it will do multiplicative inverse, meaning it will divide. So we can write x is equal to 18 over 9. 9 into 18 is 2, so x is equal to 2. So what we're saying, in order for these both equations to work, or let's say differently, if we were drawing 2 lines to represent each equation, then they would intersect where x is equal to 2. And if we know that, then all we need to do to figure out the proper coordinates of that intersection would be to find the y value. So let's substitute x equal to into any of the equations. So I'll pick equation 3. I've found that to be very easy when we have it y equal to something. So y is equal to 3 minus 2x, and we know x is 2. So we can substitute that. Y is equal to 3 minus 2 by 2. And y is equal to 3 minus 2 2s are 4. And we can solve that. Y is equal to 3 minus 4, which is minus 1. Thus, for this simultaneous equation, the solution is x equal to 2 and y is equal to minus 1. That will be the point where they intersect. Let's see if we're correct. If we take 2 and minus 1 and put it back into equation 1, does it work out? 2 2s are 4, minus 1 is 3, so it works. And if we use 2 in the second equation, 5 2s are 10, minus 2 by minus 1, that's plus 2. 2 1s are 2, plus 2. 10 plus 2 is 12. So only for these particular values of x and y do both equation 1 and equation 2 work simultaneously at the same time. Now, for part C, last part of the question, the table below shows corresponding values of the variables x and y, where y varies directly as x. So if y varies directly as x, this is called a directly proportional question. And we have a couple of videos explaining directly and indirectly proportional. So you can take a look at those as well. So let's see. They gave us a table, x and y values. When x is 6, y is less. Y is 3. When x is 10, y is something we don't know, that's u. When x is something unknown, let's call it t, we know y is 9. So let's calculate those values of u and t. Now, since they're directly proportional, then we can say y is equal to k times x. And there are 3 variables there. Let's pick the first column where we have 2 things, 6 and 3. So if we substitute that, we get 3 is equal to k times 6. Now notice what happened. We moved from 3 variables to now with the substitution to 1 variable alone, 1 unknown. So we can solve for k. So if 3 is equal to k times 6 and we want k alone, the 6 is multiplying on the right hand side. When I carry it across, it will divide. So it'll be 3 divided by 6 is equal to k. And we could cancel 3 into 3, 1, 3 into 6, 2. So that means 1 over 2 or half is equal to k. That means I can rewrite the equation. Instead of saying y is equal to kx, we can say y is equal to a half x. So that is showing that whatever value x is, if we find half of that, it'll give us y. Look at the first pair that we had. X was 6, half of 6 is 3. So it makes sense. So now for the second column, we know x. X is 10. So if we know x, then can we find the y value? Let's call it u. Then let's substitute. U is equal to half times 10. Substituting the values from the third column, sorry. So what is half of 10? 2 into 2, 1, 2 into 10, 5. Half of 10 is 5. So u is equal to 5. So when x is 10, u is 5. That maintains that they're directly variable. And for this last column, y is equal to half x. We know y is 9. So how do we get 9? 9 is equal to half times t. And if we want t, we have on the right hand side, we need to get rid of the 2 which is in the denominator. The 2 below means the 2 is dividing. When I carry it across, it will multiply. It will end up in the numerator. So we can rewrite it. 9 times 2 is equal to t. As such, 9 2s are 18. So 18 is equal to t. So we've completed the question. May 2017, number 2. A. Factorize the following expressions completely. Part 1. 6y squared minus 18xy. Now, you can immediately factorize this, but for those who are getting problems with it, let's break it up. So we can rewrite 6y squared as 6 times y minus, what's 18xy? 6 times 3 times x times y. And why do we write it like this? So we can easily identify what is the same in both terms, so we can factorize it or pull it out. What's the same? 6 and y. So we could pull that out. And what remains? Y minus 3x. And that's it. And let's see. Let's multiply it back to see if we get our original answer. 6y times y, 6y squared. 6y times minus 3x. 6 3s are 18. xy. A plus and a minus is a minus. For part 2 now. 4m squared minus 1. And there are a couple of ways to do this. 1, we can break it up. Break the two terms into 3. So we get 4m squared plus 0m minus 1. And we look at the middle term. Let's underline it in green. That's 0m. So we want to split that into 2 terms. So we could get 3 terms moving to 4. So what do? We multiply the ends. 4 times 1. 4 ones are 4. So let's put 4 squares in a row to get a rectangle. So we get a 1 by 4 rectangle. And can we get another rectangle or square from it? We can shift it around. And therefore we could get 2 by 2. So either 1 by 4 or 2 by 2 is the pairs that we can use to give us 4 squares or 4 cubes. So how do we get 0? We need to use 2 numbers which are the same. So we can't use the 1 and the 4, they won't give us 0, but we can use the 2 and the 2. Do we add them? Do we take them away? Let's switch around the signs and see which one works. So 0 is definitely not equal to plus 2 plus 2. So it doesn't work for that one. 0 is equal to minus 2 plus 2, so it works there. 0 is also equal to plus 2 minus 2. 2 take away 2 is 0. And minus 2 minus 2, it doesn't work for that. So either the second or third terms will second or third lines will help us. So we can replace the middle term, so we're moving from 3 terms to 4 by rewriting it. 4m squared, just as above. And what is 0m? 2m minus 2m, take away 1. So we can see the second line is the same as the third line. And what do we do when we have 4 terms? We put the first pair together. Let's underline it in maroon. 4m squared plus 2m. And what can we factorize out? 2m. So if we pull out 2m, we're left with 2m plus 1. And we want to get the same brackets with the next pair. Let's underline the next pair as purple. So minus 2m minus 1. What can we do? We want to get 2m plus 1. So we could pull out minus 1. And as such, what is the same? The brackets. So we can pull out 2m plus 1. And we're left with 2m minus 1. And that's our answer. Or we can do a different way of solving it, which is quicker. 4m squared minus 1, we could recognize 4m squared is really 2m times 2m. So we could write that as 2m squared minus 1 squared. And if we have a squared minus b squared, factorizing the difference of squares, we're going to get a plus b by a minus b. So we're going to get 2m plus 1 by 2m minus 1. Either solution is fine. Let's go to part 3. 2t squared minus 3t minus 2. This looks just like our second line in part 2 because we have 3 terms. And what do? We underline the middle term, and we're going to take that term and try to split it into 2 to get 4 terms. So what are we multiplying? The two n numbers. 2 by 2 is 4. And we could use the same diagrams from part 2. We have 4 squares there, 1 by 4 or 2 by 2. So which one will give us 3? 2 and 2 will not combine to give us 3, but maybe 1 and 4 can. So let's look at it. If we put 1 plus 4, minus 3 is not equal to that. And minus 3 is not equal to minus 1 plus 4. We're switching the signs around. What about if we switch the signs again and put plus 1 minus 4? Yes, it works. Minus 3 is equal to plus 1 minus 4. So that is what we're going to use. But I'll just show you the last one as well. Minus 1 minus 4. That doesn't give us 0. So clearly, to split the middle term, the minus 3t, we can use our third line. Plus 1t minus 4t. So let's rewrite this first line. So we're going to get 2t squared plus t, or 1t, minus 4t minus 2. And let's check. 1t minus 4t is minus 3t. So the first line is equal to the second line. And since we have 4 of them, just like in our third line in part 2, we can underline them with maroon and purple to separate the pairs and factorize each pair. So the first pair, 2t squared plus t, we can pull out t, and we're left with 2t plus 1. And we want to be left with 2t plus 1 again, so we could pull out minus 2. And what's the same in both of them? The bracket, so we could pull that out, and when we factorize it, we get 2t plus 1 by what is the remainder? T minus 2. And for part B, write as a single fraction and simplify the following. 5p plus 2 over 3 minus 3p minus 1 over 4. So let's recall that in order to simplify it, I found that it's easier if students put brackets around the numerator, so I'll rewrite it. So you get open brackets or open parentheses, 5p plus 2, close parentheses, over 3, minus open brackets, 3p minus 1, close brackets, over 4. And if we're adding or subtracting fractions, we need to have the same denominator. We have 3 and 4, they're different, so how do we get the same? What we can do, we can multiply them, and we get a common denominator. So we can say 4 times 3 for the first fraction in the denominator. So if we multiply by 4 below, we multiply by 4 on top. 4 times 5p plus 2 minus 3 times 4. So we multiply by 3 below, so we multiply by 3 on top. 3 times 3p minus 1. So now we know both of them have the same denominator, which is 12. As such, we can multiply or expand the brackets on top and replace the two fractions by one denominator of 12. So let's do that. 4 by 5p is equal to 20p, plus 4 by 2 is 8, minus 3, don't forget the minus sign, minus 3 times 3p, 3 3s are 9, minus 9p, minus 3 times minus 1, 3 1s are 3, minus and a minus, same signs, gives you a plus. So we have 20p plus 8 minus 9p plus 3 all over 12. Now we have 4 terms on top, and of those 4 terms, 2 of them have p in it, and 2 of them have no no variables. So let's combine them. 20p minus 9p, that's 11p. And plus 8 plus 3 is 11. So we get 11p plus 11 all over 12. And if we can simplify it a little more, factorize it a little more, we can extract the L from the top. So we could get 11 by p plus 1 all over 12. And that has completed the simplification of this as a single fraction. May 2017, number 2, part C, the last part of the question. A formula is given as d is equal to the square root of 4h over 5. Part 1. Determine the value of d when h is equal to 29. So that means they're asking us to do a substitution. Give your answer correct to 3 significant figures. So let's rewrite the formula. D is equal to the square root of 4h over 5. Let's take a couple of seconds and think about what we need to do here. We can substitute h is equal to 29. So d is equal to square root of 4 by 29, 4 times 29 over 5. We can use our calculators and that works out to be 23.2 exactly. So d is equal to the square root of 23.2. And using our calculators, we will get d is equal to 4.81663, going on and going on. And look at what they're asking us. They're asking us to give our answer correct to 3 significant figures. So the first significant figure, or the figure with the most value out of all those 6 digits that we just wrote, is 4. Because that's the value is 4 ones. And then the next most significant is 8 tenths. And then finally 1. So therefore, if we're writing into 3 significant figures, we should end at 1. But notice something. We need to look at the number after it to recognize whether or not we need to keep the 1 as is or to round it up to 4.82. And since the number after is 5 or more, it's 6, then we need to move it from 4.81, it's closer to 4.82. And for part 2, the last part of the question, make h the subject of the formula. So let's recall the formula. D is equal to the square root of 4h over 5. And we want to get h alone on the right hand side. So we need to remove everything. We need to remove the 4 from it, the 5, the square root. So the first thing we can do is remove the square root by squaring both sides. Remember, the opposite of square root is squared. So if we square both sides, d becomes d squared is equal to 4h over 5. Now, let's remove the 5. The 5 is dividing on the right-hand side. When I carry it across, it will do the opposite of division, which is multiplication. So we'll get 5d squared is equal to 4h. And if we want h alone, we need to get rid of the 4. The 4 is multiplying on the right-hand side. When I carry it across, it will divide. So we get 5d squared over 4 is equal to h. And that's it. The question has been completed. May 2018, number 2, part A. Factorize completely each of the following expressions. So let's look at part 1. 1 minus 4h squared. And we've done it and explained it multiple times in the long method and the short method. So we'll use the shorter method here. And why we can do that? Because we can rewrite that as 1 squared minus 2h all squared. Because 2h by 2h, 2 2s are 4, h by h is h squared. So since we write it in this form here with the difference of squares, if we're factorizing it as a squared minus b squared, then that will give us a plus b times a minus b, where a is 1 and b is 2h. So our answer will be 1 plus 2h by 1 minus 2h. For part 2, factorize pq minus q squared minus 3p plus 3q. Now there are 4 items here. Take a minute and think how we're going to factorize that. So what we've been doing all the time is we've been putting a maroon line under the first 2 items and then a purple line under the next 2. So if we do that, then we can see in the first 2 items, what can we extract? What's the same in both terms? Q is the same. So if we factorize out the q, we are left with p minus q. And let's double check. Q times p, that's pq, minus q times q, q squared. And just a little reminder, you can write QP or PQ. It's just a standard form when you look at textbooks and stuff that they write it in alphabetical order. And in the second part, under the purple line, what do we want to extract? P minus Q. We want to keep the same brackets. So what are we going to take out of that? What are we going to factorize? Minus 3. Minus 3 times P will give us back the top, minus 3P. Minus 3 times minus Q will give us plus 3Q. So now we can complete it. Since we have the same brackets in both of them, we can pull it out. And what we're left with? Q minus 3 times P minus Q. Or we could switch it around and it will still work. And let's recall that in both of these questions, we can multiply our answer at the base and see if we get back what's on top. For part B now, solve each of the following equations. And they give us two equations. So let's look at part 1. 3 on 2y is equal to 12. So if we want to solve that, what they're really asking us is to go and find out what value y is, so that when we multiply it by 3 on 2, it's going to give us 12. So what we do, we can get rid of the items on the left side to leave y alone. So the first thing to get rid of will be the 2. The 2 is in the denominator, or dividing, so when I carry it across, it will multiply. That means we're left with 3y is equal to 12 times 2. So if I want y alone, I need to remove the 3. The 3 on the left side is multiplying, so when I carry it across, it will be doing the multiplicative inverse or dividing. So therefore we get y is equal to 12 times 2 divided by 3. And you can use the calculators, or you can cancel off 12 2s are 24, 3 into 24, 8, or 3 into 12, 4 2s are 8, same thing. So it's giving us y is equal to 8. And you can double check if that answer is correct, because if we use our calculators and say 3 on 2 times 8, it should give us 12. So we know we got the correct answer. And for part 2, it's a quadratic equation we have to solve. 2x squared minus 5x minus 3 is equal to 0. So how do we do that? Let's deal only with the left-hand side, because the right-hand side is already equal to 0. So what do we do with the left-hand side? There are a couple different ways to do it, to solve this. Let's take a minute and see if you can remember which ways. One way is that we can use the quadratic equation ax squared plus bx plus c, where a is 2, b is minus 5, and c is minus 3, and solve it using x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Or if you want, you can factorize it just as we've been doing before. So how do we factorize it? How do we factorize it? 3 terms, we try to make it into 4. So let's recall that the green line indicates the middle term, which is what we want to split into 2, so that the 3 terms now becomes 4. That's minus 5x. So how do we do that? Our first step would be to multiply the numbers on the end. 2 times 3, and 2 times 3 is 6. So we can put 6 cubes at the bottom there, and it'll form, we could form a rectangle with them and get 1 by 6. Or we can shift it around and get 2 by 3. Can we do anything else? If we shift it, we'll get 3 by 2, which is the same thing. So either we have 1 by 6 or 2 by 3. Which one of those will give us minus 5 when we manipulate it? Well, actually both of them. But let's choose a pair and see if it works. And if it doesn't work, then we'll choose the other pair. So let's choose 6 and 1. So if we say plus 6 plus 1, remember when we choose them, we're going to manipulate them by changing the adds or take away in front of the signs to see if it works out to be that middle term, which is minus 5. So plus 6 plus 1, that's not equal to minus 5, so that doesn't work. What about if we change the sign in front of the plus to negative, then minus 5 is equal to minus 6 plus 1, right, so it works. So we're going to use that. So we write the line 2x squared plus 1x minus 6x minus 3. It's the same thing as writing the minus 6 plus 1 or the 1 minus 6. It both works. So now we have 4 terms, just like part 2. Let's put our maroon line there and factorize those. We can pull out x from it. We're going to left with 2x plus 1. And let's multiply x by 2x. 2x squared, x by 1 is 1x. And let's put the purple line now and see we have minus 6x minus 3. When we factorize it, we want to end up with the same brackets, 2x plus 1. So what do we pull out? Minus 3. Let's check it. Minus 3 by 2x is minus 6x. Minus 3 by 1 is minus 3. So now we can complete the factorization because both of them have the same bracket. So we have x minus 3 by 2x plus 1. And that is equal to 0. So how do we solve it? Now let's recall that if we have 2 items and when you multiply it, it is going to give you 0, then it means one of the items is 0. We don't know which one, either one, but one of them is definitely 0. So let's write that. Either the first bracket, x minus 3 is equal to 0, or 2x plus 1 is equal to 0. So if x minus 3 is equal to 0 and we want to find for x, then we carry the minus 3 across and it'll just give us 3. So when x is 3, this works out to be 0. If you put it into that line above, you can see that 3 minus 3 is 0. 0 times whatever it is will give us 0. Or if that's not the case, because you're going to get two answers instead of quadratic, then 2x is equal to, take the plus 1 and carry it across, we'll get minus 1. So 2x is equal to minus 1. So x is equal to minus 1 over 2, or minus a half. So either one of these will give us the correct answer. So those are your two solutions. May 2018, number 2C. The quantities f, m, u, v, and t, those 5 quantities, are related according to the formula f is equal to m brackets m v minus u over t. And actually for the physics students, if you know this, this is the formula relating force, mass, and change in velocity. So part 1. Find the value of f when m is equal to 3, u is equal to minus 1, v is equal to 2, and t is equal to 1. So what they're telling us, they're giving us values, substitute and solve. So let's write the formula again. F is equal to m, v minus u over t, and f is equal to 3, because m is 3, open brackets 2 minus, what's u? Minus 1, close brackets, all over t, and t is 1. 3 by 2, and we have minus 1, so two negatives, two of the same signs means we're going to get a positive. So that's 3 by 2 plus 1, all over 1, we could ignore the 1 below. So 2 plus 1 is 3, therefore f is equal to 9. And for part 2, make v the subject of the formula. So since we have the formula f is equal to mv minus u all over t, we need to get rid of everything on the right hand side except v. So the first thing to move across would be the t. The t is in the denominator, it's dividing, so when I carry it across it will multiply. So we'll have ft is equal to m by v minus u. And what's the next thing we can move from the right hand side? We can move across the m. The m is multiplying, so when I carry it across it will divide, so we'll get ft over m is equal to v minus u. And if I want v alone, I get rid of the minus u. The u is subtracting on the right side, when I carry it across it will add. So we'll have ft over m plus u is equal to v. This brings us to the end of CSEC past paper questions on the topic of algebra. Specifically, the algebra questions that come in paper 2 section 1. In our first video in this series, we completed the past paper questions from the years 2009 until 2013, and in this video we did from 2014 until 2018, and in our next video we will be doing from 2019 until the present. Feel free to look at the description down below so you can get an overview of all the solutions from May 2009 onwards, so you can follow the order we suggest in order to cover the entire CSEC Maths syllabus so you can get a better understanding.